Mr. Vikram Gandotra. Mr. Vikram Gandotra is an accomplished professional with extensive knowledge of the power transmission and distribution sector, particularly digitalization application for power utilities. Mr. Vikram is a member of IEEMA's National Executive Council, chair of the World Utility Summit, and past chair of Smart Grid Division. His present position is head Utility Sales and Strategy, Siemens Ltd. Today, Mr. Vikram will elaborate on the role of the energy management system for the power utilities. So delegates, let's welcome Mr. Vikram.
The title for today's presentation I have kept is Walking the Tightrope. Now, I will, through the presentation now, tell you why it is so. And I think everybody knows what a difficult thing it is to walk on a rope, when you cross from one place to the other. So that is the sort of challenge which our grid managers are going to face in the coming days. And thank you, EPR, for giving this opportunity to share my views. So what are the current mega trends? Of course, you would have seen all this everywhere: climate change, digitalization, urbanization, where flexible working hours, etc. What we are seeing all the time. Yeah, and if I can I not minimize the screen? Yeah, okay. Thank you. Now, what is happening is, of course, due to the COVID, we are also now seeing flexible working hours, and we are spending a lot of time within buildings. So for example, now some of the challenges are like our population is expected to reach 9.7 billion by 2050, a huge number. Never before, these sort of numbers are there. The pressures which are there on our planet. Then 68% of our world population will live in the urban areas. Yeah, so most of this population, it is going to shift from rural areas. It is already shifting, but that will continue. It will not stop, and it will shift into urban areas. And 90% of our people spend nearly all the day indoors. Yeah, that is just to show how important the building sector is as far as the power consumption is concerned. Currently, we have about 30 to 40% of the total energy that is generated, that is consumed in the building sector, within the buildings. So coming to what is the summary for the energy supply. The companies which are involved in energy supply, their challenge is always to ensure that the power is reliable, it is efficient, and it is sustainable. If you are a consumer as an industry, your outlook is towards performance, your efficiency, cost reduction, life cycle or optimization, flexibility. And if you have a building sector, then the trend is to go towards adaptable and flexible building, human friendly buildings, human centric, energy efficient and sustainable buildings. Now the utilities, they need to rethink their IT OT landscape to overcome these challenges. Now let's see on the right side. One is that the grid is running closer to its limit than ever before. There are so many fast growth of the loads which is there, especially the peak load, and it is very challenging for utility engineers, managers to make sure that they are able to supply reliable power. They are having a lot of problems. They do not know what is the situation on the low voltage side. And, this is not only in India, it is across the world, because nobody ever gave that thought how to monitor that. Then we are talking about congestion of the network. Even if there is a generation which is there, sometimes it gets stranded and not able to supply because there is a congestion in the grid and voltage problem. Now next thing which is happening is this distributed energy resource. So distributed energy resource is the generation which is there in the distribution level. It is the loads which are there, which are the new roads which are coming, the distribution, like the EVs. Now the problem with them is, although they are very environment friendly, they are a big headache to the people who forecast the demand, because you do not know where it is going to come, when it is going to be available, when it is not available. And same is a challenge for charging. Now this is one of very big challenge when we talk about renewable energy and electric mobility. Now field crews. Now it is very difficult even today. I mean, it is very difficult to know exact location where a cable fault would have taken place. Even in the age when we are living today, where Uber we are able to know, or Zomato we know exact location where our pizza is, on which street, when it will come to my house. It is still not possible for engineers and managers to know exact location of a fault of the network when it takes place. So that is a problem which we have in the transparency of the situation what is there. And LV digitalization is now taking place. Lot of smart meters one would have thought and read are coming, and this will provide lot of information which is there. But another challenge is the data which is available. It is available in separate silos. Yeah, so they are very difficult to make them useful at the time of taking some decisions. Now let us look at some focus area. Now, if you have come across this term grid edge, very good. But if you have not, this is a new term which will be more and more in use in practice. It is a dimension between the intelligence which is now built in the grids, in the smart buildings, in the generation, and it is important because it brings about new business opportunities and helps to make the world more sustainable. So what happened earlier was that on the left side we had the energy supply world, and right side was the energy demand world. They were very two distinct, and the transmission was very solid in between the two, and they were working, if not independent, but at least they would not affect the two sides. One would not affect the other so badly. However, this distance has been reduced. What is to be called grid edge. In the grid edge, what is happening is that there are newer topics which are coming, like distributed energy solution, renewable integration, electric mobility, which is coming. There are distribution, system operators, and the old utilities are, of course, always there. But now these new players are also coming, like virtual power plant, and energy trading is happening in a big way. So that is again demanding a lot of data and ability to control and forecast the power. On the other side, in the load side also, there is no single load, because you see all the loads also are increasingly becoming generators as well, and they are also monitoring their economics of the operation. They are monitoring the reliability of their operation. So a lot of data is getting generated, and also this needs to be controlled properly so that there is absolute stability of supply. And there are topics like microgrid, building performance, energy monitoring, etc. All of these are coming, and in between this, it is for OEMs like us from Siemens to develop solutions which are able to meet all the requirements on this side. Then another dimension, what is happening from, if you see on the left side, from the year 2000 to 2025, the prediction was, of course, that the generation is going to become more and more decentralized. So from bulk power generation to digital, automated microgrid, energy storage, all this is going to come. And on the load side also, there is going to be, earlier was very primitive control of the building electricals. More and more smartness is coming in the buildings, and the smartness will also go up to the level of AI. Now what it means is that from both sides, from generation side as well as from load side, huge amount of data is getting generated, and or will be continue to get generated, which will be pumped up, and this will have to be managed and used in a way that it is a sensible data for taking decisions. Not just raw data, but sensible decision making data which will be required. And this is always happening at what we call the grid edge. Now so another look at the future is, how do we manage now? If you see, this is the capacity which is installed capacity. Our Indian grid is also growing at a very fast pace. More and more of this is the bottom side. If you see, earlier renewable was a small percentage. Now, if this is the growth in conventional electrical generation will be there, of course. but it will be far and far overtaken by the growth in the renewable, which will be like the base. In earlier time, before 2000, it was the other way around, that the base growth was always more and more of fossil, and the rest was all renewable, biomass, blah blah blah, all the other things. Now this is creating a lot of challenge, because this, as I said, is we all know is unpredictable, and it is also limiting. Yeah. So what that means is that this hosting capacity will be dependent a lot. Hosting capacity means to bring in this power and manage this growth in power. Our conventional electrical systems, they have a limited capacity to grow. So if you see that these bottom layer here we are showing that this conventional electrical networks will also continue to grow to meet the increasing demand. However, there is one very big element which is growing much faster in this whole requirement in hosting these renewables and DERs, and that is going to be the software. So more and more types of applications, more and more types of software are going to come into picture, which we will need to manage this growth of power system and to manage the growth of the loads, in the sense that there is always 100% reliability of our supply, and whenever the consumer turns the switch on, electricity will be available, whether it is coming from fossil or it is coming from wind or solar. Everything should be available. The customer, when he turns the switch on, he does not care at that point of time whether the wind is blowing or there is a cloudy day. He wants electric supply. Yeah, so that is going to be possible with more and more of intelligence and softwares which will help us do that. Now I will show you one example. Now typically there are three types of operations, or there are three types of dimensions which are there in the way or the activities which are done by the utilities. One is of course planning, then operating, and maintenance. Yeah, and planning includes grid planning, protection planning, asset in managed planning, network model management, and operation will have things like SCADA, DMS, EV charging system, billing, meter data management, protection, grid control, etc. And maintenance, of course, is mostly a topic of asset management, workforce management, condition-based monitoring, and outage management. So when I see how things are, earlier time they are all in different silos. Now we are going to bring them all closer together so that real-time data is available even for planning purpose, and for operating also we have absolute real-time data. Now, how will this change the you know the operation? So earlier we were without this availability of so much of inputs from the data. What we were working using our hindsight and our experience. And this is what is we call the descriptive or maybe a diagnostic way of working. That what could have gone wrong? Maybe because there is a no power supply, so we will say that go and check the XYZ street circuit breaker. Yeah. Now we are having better insights, and we know exactly where to go after we get this information, and we are able to go into a next level. Now next level will be a predictive, and that will mean that we are able to predict through foresight if certain sets of conditions are there in my network, what is the likelihood of a fault coming after a year, after a month, or any after a day, depending on how sort of algorithm that we are able to build, and then we are able to use that to predict and then give a perspective. And eventually we are going towards a world where it will be autonomous, depending on all this data which is there, all this information and all these algorithms that are coming up, and it will help us build such sort of systems. So that is, of course, too far away, but still, at least the people they are who are thinking about this, they are looking at the ways how to go in that direction. So, what are the basic design principles whenever we make intelligent software control centers? One, that the systems one should be interoperable, means that interoperable with another system. It should not be that we are living in a world of silos, and modular. So modular means that if we have got, say, a system today, if utility wants to buy only two of those functions, they can go only for two. After maybe 3-4 years, they are mature. They can go in for another set of functions. So that is a modular way. You don't need to buy everything today, or you don't need to buy something which you don't know or don't need just because the supplier wants to supply that. And open system. So open system means that there are, of course, different manufacturers, there are different systems, there are different types of systems also, which should be able to exchange the required information from one to the other. Resilient and cyber secure. This I need not tell you. You are all aware of the type of attacks that we are seeing. So whatever IT system that we build and that we use must follow the required norms for cyber security, and of course collaborative. Yeah, so one has to go away from the earlier thought process that I will own everything, that I will build everything, I will be the only vendor, or that sort of thing. Now it is more of a collaboration between the various people, that yes, we have to find the most efficient way to work. We have to find the most economical way and the most reliable way to produce a system which is useful. Yeah. So let us take an example of the meter data management. Yeah. So using the meter data management tool, we are using newer some innovative user interface, and there have been fantastic savings. For example, 85% reduction on clerical tasks which are there. Additional cloud native, lower total cost of ownership. Yeah, so earlier we were only giving on-premise the system. Now today we know that we have collaborate and we have to use cloud wherever it is making sense, and that is going to reduce the total cost of ownership for a utility. Now grid planning. Now grid planning is another function which is there. So there we have seen that, for example, using some new tools and algorithms, we are able to do the planning much faster, and using the cloud also we are able to increase the speed, say for example in one particular example, more than 100 times. Yeah, so now the meter data management, it is giving real-time information, and the grid planning software, they are using traditionally offline data. But what we have managed to do is to bring this meter data management using this data into the grid planning, and through network model management and data exchange and integration, we are able to tell the utility or give suggestions how to reduce the technical losses. The next topic is grid control. Grid control is to managing the grid, that it remains within safe limits. Here also we have got examples where using the same lines through dynamic line rating, we have used to transfer 30% more power. Yeah. The next generation of this grid control, as I said, will be towards meeting and visualizing and controlling the lower end of the grid, that is the LV side. Currently, nobody really knows exactly, because it was never economical to bring in a lot of automation into the LV side of the grid. So now here I am trying to bring to you out that there are various bricks which are used to make a software utility suite. Yeah, one is of course the meter data management, SCADA, DMS, DERMS, field connectivity. So all this is the softwares which are connected to the devices which are there in the meter, whether RTU to SCADA, DMS, or meter to meter data management, or some controllers to DERMS. Yeah? And using this data which is here, the next level is using network model management and exchange of data for with other systems like grid planning system, with LV situational awareness, outage management. So, there is this purple color layer which is joining this field data with the other application. Yeah? So, of course, eventually what we say is that the electrical world's digital twin will comprise all these modules and create a situation where the managers and utility engineers will be able to know what is the impact of the various conditions on their grid and how to overcome that and make the grid reliable and economical to supply. So, so this is what I explained. These are critical operations. Then these are the integration layer, IT/OT, and these are the business critical functions. Yeah, and on top of it are the external systems like the asset management, GIS, CRM, customer relationship management, billing, and workforce management. Now, how does this translate into some of the priorities, into the benefits which have been seen? Yeah, so resiliency is one very major point. Security and reliability. So operation, maintain, develop of a secure, reliable system. So here there have been the KPI which is used is SAIDI. Yeah. So SAIDI and SAIFI are the two parameters which are used to monitor the reliability of a network. And this is SAIDI is average interruption duration, and SAIFI is average frequency of the interruption. So this is how they are measured, and there is an example with energy IP meter data management using in this city of C-Start Aspen, which is there in Austria. They have reduced their the SAIDI by about 10 to 15%. Yeah, that is a huge number, especially once you have already managed to do it, make the system reliable at medium voltage. At low voltage comes a lot of challenge. Then another is, they say, efficiency and regulatory compliance. So here there is example that there is 85% task time reduction using this for the Mosaic user interface. Then renewable integration, capacity increase, timely connection of new capacity to the grid. So we have the softwares which were used with Finnish grid to reduce the effort for model creation and data collection by as much as 60%. Yeah? And management and coordination of distributed generation. So here again we have example of this microgrid management. Here we have in one location only for the one microgrid, they have saved about $3.2 million, and information flow and customer satisfaction. So here we have a large number of examples. Some say, for example, in the case of electric mobility charge points, the availability is known via these systems. Say 130,000 charge points availability is known in Italy. Yeah, so this is also an example how softwares are working. So one application that we do is to use these softwares to do electromobility test for a municipality or a city distribution system in what we call as a stress test. Yeah, so here we say that what will be the effect of the grid when increasing number of electric vehicles are going to get charged. So this is for some examples which we have done for some cities. And California ISO is very large system. Here we are doing this market management. That is the energy market. So 30 million people are served by this, and this is something which we have achieved in the USA, and it's a very complex system. That's just to show that even on the transmission side we are doing something. And then the new meter data management system for consolidated. These are the utilities. Yeah, and in New York. This is a utility where Siemens system is being used, and this is helping them to not only look after the electricity meter but even gas meters. Yeah, they are connected to this, and they have a 15-minute delivery, nearly what we call near real-time data, and they have got very good visibility into the low voltage grid after this. So with that, I come to the end of the presentation. Thank you.